So maybe
yeah, we can relay for you, Bryan.
Alan or Kyle can relay any questions to me. Yeah. Okay, so I'm glad actually that I've seen that several people have mentioned WISE, so I know a lot of you are familiar with the mission. So I won't say too much about it other than WISE was a NASA telescope that surveyed the whole sky throughout 2010, and it did it in 4 infrared wavelengths. The mission is now over, but the data are just becoming available, and so really the adventure for teachers and students, I think, has really just begun, because now the data is out there and it's time to have some fun with it. As of right now, we have released 57% of the sky, and that may seem like somewhat of an odd number, and it kind of is, and it was all based on NASA requirements and how long the mission operated and whatever. But 57% of the sky had to be done within so many months of us completing the mission, and then by next spring we are on track to deliver the entire sky. So by March of 2012, the whole sky should be available. And the way you can access the data is through IPAC, and this is the Infrared Processing and Analysis Center. Oops, yeah, I see that my sharing just stopped, and I also had seen a quick message from Harlan that was saying he couldn't see my screen. I wonder why. Let me try, maybe I'll try to share the application instead of sharing the desktop.
Oh, there you go.
How's that?
Now we can see your desktop.
You can see the desktop?
I mean, that's your application, I guess. Yeah.
Okay, yeah. So this is the Firefox. So you all should be seeing the NASA IPAC Infrared Science Archive page.
Yes.
Yes.
Harlan,
Okay. And Harlan, are you seeing that online?
I think if you click on full screen, you'll get rid of some of the edges of that.
I'll try it. This is. Yeah, I don't know. Let's try it.
Oh, you guys are going to try to go full screen with yours? Yeah. Good luck.
Okay, you got.
Kind of. Looks good on this thing.
Yeah, it's okay.
Okay. All right. Great, and Harlan can see it too. You can get to this page from the main WISE website, which, if you haven't seen it already, we can show it to you at the end. And then for right now, the WISE image service is featured on the URSA site, and I presume it will be for a while. If you click the logo, you get this page which will give you all kinds of information, probably more than you ever really wanted to know about the mission, and actually with a map of the part of the sky that's currently available at the bottom. The first link is the image service. Besides the images, the other data we have released is a catalog of sources that have been detected in all 4 wavelengths. And I believe we have something like we're approaching 200 million objects are in that source catalog right now, and we will have well over 300 million in the final catalog. So there's a whole other world of data besides the images, but we're going to show you guys the images today. So click on the WISE image service, and it brings up this search tool, which has a lot of different options. And I'll mention what some of them are, but in most cases it's probably going to be simplest to try and stick with some of the defaults. So you'll notice on the left side there's the search by. Position is the default, and that's if you're going to basically be looking for anything that's a fixed object in the sky, stick with position. The other ones are probably only useful, well, scan frame and coads, those may become useful to someone who becomes very, very deep in the data and they know exactly which frame or exposure they're looking for. The WISE source ID, I think, is if you are working with the catalog and you actually have found a source and then a catalog and you want to see the image, then that would be a useful way to search, is to actually search on that ID rather than trying to go by position. And then there's an option for looking for solar system objects. So asteroids and comets that WISE detected during its survey, you can pull up images of those, and you need to use a different search since they moved. And the number of those that are available is a little bit overwhelming. Hundreds of thousands of asteroids were observed by WISE. So yeah, you could have a lot of fun there. But for right now, I'm just going to show you searching by position, and I think I'll use the object that Kyle's going to show you as our example object to search on, which is going to be Zeta Ophiuchi. So you can type in either the name of the object or you can type in coordinates, and it depends on which you know better. If you have a name, then you can type it in a whole bunch of different ways, and the system should be able to recognize most things. In fact, I didn't really need to type all of the constellation Ophiuchi there. It would have recognized Zeta Oph. And it says Zeta Ophiuchi is resolved by Simbad. So Simbad, there's two different databases that you can look up objects with. Simbad is the default. That works best for things that you're looking for that are located inside the Milky Way galaxy. If you're looking for objects that are outside the Milky Way, then the other one, NED, is probably the fastest. Although there are many large galaxies that Simbad will also find. But if you're going to start looking for galaxy clusters or small galaxies, then NED is probably the one to choose. And you can see that when I typed in Zeta Oph, when it says resolved by Simbad, that means it found it in the Simbad database and then it automatically gave us the coordinates. And so those are listed down below, are the coordinates of this star. And then we move down to, okay, what kind of image do we want to actually pull up? If you just stuck with the defaults, what the default is going to return is it's going to give you an image that contains the target you've searched for, which that's good. That's the whole point, right? It is going to then also give you back some cutout of the sky. Now, the way the images are being served up is they are being served up as either single exposures or combined what we call atlas images. So the telescope was taking pictures constantly as it was in orbit around the planet. And it was taking one exposure every 11 seconds. And those individual pictures you can actually search for. Those are the single exposures, which you can see down at the bottom as an option to download. And then what the team has done is basically divided this whole sky up into a grid of tiles, what we call atlas tiles. And then we've combined all the single frame images to make the atlas tiles. So the atlas tiles take all the data, combine it together so that you get your best signal to noise. You remove all the instrumental artifacts. Well, not all the instrumental artifacts, but all of the important ones. So when you're searching here, it depends on whether or not you're going to be looking for those single exposures or you're going to be looking for pieces of atlas tiles. So if you choose something, some random size here, it will basically be a smaller portion of the full image, either the full single exposure or the full atlas tile. Generally what I like to do is just to grab the whole thing. I want the whole single exposure or the whole atlas tile. And the way to do that is simply to leave this blank. If you leave that blank, you're going to get the whole picture. And then depending on whether or not you've chosen single exposure or whether or not the atlas tiles overlap on the coordinates you're searching on, you could get back many pictures. And you do have the option of saying, well, I only want the one where the image is the most centered. And so that's where you'd answer yes. If you only want one image, you want the one image where this object is most in the center of the picture. I'm going to leave it no for now. And then there are 4 wavelengths that the telescope observed in, and you can choose just to retrieve 1, 2, 3, or all 4 of those images. And then you have the choice of looking for either the single exposures or the combined exposures, the atlas. And then there's additional constraints, which probably not that useful for you all. If you're interested in specific dates, you can try and enter there. But the more you constrain it, the more likely it is you're not going to find anything. All right, and then you hit search. Now, if you had been searching on an object that happens to be in the 43% of the sky that is not released, you'll get a message that says no results are found. So for example, if you searched on Andromeda Galaxy, it would say no results found because Andromeda is not in the released portion of the sky. Okay, so what it is showing me now is it's showing me actually some previews along the bottom of all 4 of those WISE bands. In the little coverage window, there's actually a background image that's from the IRAS survey. That was another infrared survey done back in the 1980s. And all those red boxes are all of the images that have been returned. The blue one is the one that it's showing you below in the preview area. So that blue box is the footprint of the image that you're seeing below. And it's also, hopefully your projector can show seeing the color. You'll look in the results box. There's a whole bunch of list of each one of these lines as an image. And the ones that are highlighted in green are the ones that are being shown below. So those are the same as the blue footprint over yonder. You'll notice there's 2 tabs. There's a tab for the single exposures, and then there's also a tab for the atlas images. So I'll just show you that if you click, and they're always highlighting in groups of 4 because this is one shot. Every shot was 4 images because that's the way the telescope worked. It took the beam of light coming into the telescope and divided it up 4 times so that it was landing simultaneously on 4 different detectors at the 4 different wavelengths. If you click on another set of 4, it automatically moves the blue box over and you get a different view in the bottom. So these are all the individual exposures. There's lots of cosmic ray hits. There's bad pixels. You have some dark current. You have a little bit of the detectors are not, the pixels are not exactly square, and so the images kind of need to be rubber sheeted in order to be aligned. So single exposures are, if you're working with students, they're probably not the best thing to work with. The atlas image is a much cleaner product to have a look at. So I clicked over on the atlas tab, and there's only one atlas image that covers it, so that's all we get back. The preview window is a bit zoomed in. Not really sure why. You can unzoom it. If you click on the window, you get these little visualization tools, and you can back off a bit to see the full preview of the whole atlas tile. Okay, I zoomed out a little too much there. I'm not sure why band 4 is as different. There's a little bit of, I'll just say this, it's a little buggy, this system, and sometimes you'll see this. I don't know why. Usually all 4 of them should be at the same zoom level, but for some reason band 4 is at a different zoom level. Oh well. Okay, but the real thing you want to do is actually get these images on your computer and start having some fun with them. So if you simply click on them, that will basically, that's how you can select them to say that you want to download them. You could have clicked all of them by clicking this box here. You click Prepare Download, and that's going to start a job that's going on the server at IPAC that will start getting it ready. You can choose to either have the images, if you have a whole bunch of images, it will create a zip file that has subdirectories in it, and that's the default setting. I personally don't care for all those subdirectories, so I just would rather have a file that's flattened. So there's no internal folders, just everything will be in one zipped up folder. There's a whole bunch of ancillary files that you could download. These are information that are useful if you're going to do science on the images and want to know where there's diffraction spikes, where there's halos, some of these other optical artifacts that are in the images. But if you just want the images themselves, you can say Prepare Download. And there's a little spinning wheel that starts moving up there. If you click on Preparing, you can see the progress as it starts preparing the whole image. You all won't need to go through this because for this image anyway, we've placed the zip file online for you to download. And then you could download the zip file, and it'll take however long it takes you to download 200 megabytes. Okay, so that's the process in order to actually get the data. And then I think I'm going to turn it over for Kyle to actually show you, okay, what do you do, or one of the things you can do with it once you've got the data. Are there any questions before we do that?
Yeah, Bryan, Carl's got a question.
Hey, Carl.
It wasn't obvious to me how you get an asteroid.
Well, yeah, so an asteroid, you can go back to home and start the search again. You go to the search by solar system object. And then this will bring up a different search box. And you can search by an asteroid or a comet, and then you have to enter in the name. So I don't know, does anyone have an asteroid name they want me to quickly put in?
How about Martin Luther King asteroid?
Okay, what's the number? We need the, this is one of the things about it is you need the very precise number that the Minor Planet Center gives for it. So if it's a numbered asteroid, the number will do. If it's a named asteroid, it usually has a number, then the name. The number is the real important part for the searching.
Just a second. Can you take another
Bryan, I took over the projector, so I'm showing it now.
Oh, you're doing this now?
But I need to do it also on ReadyTalk.
I need to promote you.
Does that mean that I have to give back the controls?
I think Alan.
Well, actually, aren't you seeing? Don't you have his screen on yours since you're a participant? You can show his screen.
Let's see. You would think. But no, to me it shows that I'm still the presenter and I'm sharing my.
Or you yet? But
okay.
This is his. Is that his screen?
No, that's his. I believe.
So this is
my screen showing his screen.
That's right. That's his screen on your computer, just like I was doing.
And if you make push,
We can see your computer now, Bryan. Here you go.
Oh, okay. Well, how about I'll just finish the example. Carl, there's an asteroid that we're about to do a press release on tomorrow, 2010 TK7.
There goes Bryan.
And if you just do a search for that, that's actually not going to turn up a search because it's not in the preliminary release. I will show you behind the scenes. We have, actually here it is. This is on our internal server where we have all the data. This asteroid was observed actually after the coolant had run out, and we were only observing in the first two bands. But you can see there's a whole mess of observations, and these are all the observations that were made of that asteroid. The little blue box, I don't know if you guys can see that on the screen you're looking at, there's a little blue box that actually marks the where the asteroid is, and it's extremely faint asteroid.
Want to try 4984? That's asteroid Miller. 4984.
There we go. So it looks like it was observed, let's see, 60 files, so 60 divided by 4 is how many times it was observed. And you can see the blue box down here. In this particular image, it was right near that very bright star. And if we go to the next group.
I don't know if people heard, this is asteroid Patrick Miller, named after our Patrick Miller here.
Well, very nice. That one was right on the edge. So in some of these, you have to watch for it. This observation was taken right on the edge up here, very top edge of the image. And here it is again. So that's how you do a search for an asteroid. And
okay, here you go. I'm promoting you. See what happens. This will take.
Okay, so is Kyle now getting promoted?
Yeah, I'm going to promote Kyle.
So let's see. Should I stop sharing?
You should stop sharing. Yeah.
Okay. No more sharing from me.
Thank you, Bryan.
Welcome. And how about I return? Stop sharing and return.
I did run. So this is,
Okay. It shows here that Kyle's being promoted.
and Bryan, on your end, are you seeing the WISE homepage with M101?
I'm not seeing it yet. I think that's because you've not been promoted yet.
Yeah, I think it's.
Okay, now it says you're the presenter.
Okay,
Well, actually, it says that I'm also the presenter, but.
No, that's neither here nor there.
Okay.
You can remain presenter.
All right, now I see it.
Now you see Salsa J on top of the browser window.
Yep, I sure do.
Okay. So looking around just now, it looked like about half the group was really with Bryan and understanding exactly what we're talking about. The other half of the group maybe not so much. So I just kind of want to step back just a little bit to give you the bigger picture on what we're talking about. So the WISE mission was recently, it went up in late 2009, did a lot of observing throughout 2010, and it was looking at the entire night sky in 4 infrared wavelengths. And what we're talking about is how to download data directly from NASA, from the WISE mission that you can use on your own, directly from the same source that astronomers get their information from. Everything that Bryan just did is in one of those PDFs. And I downloaded 2 PDFs and gave them open for me. Oh, really? Anybody else?
I worked okay. The 2 PDFs of instructions?
Yeah. I can give it to you directly if you're still having that problem. We'll troubleshoot later. I've got copies of it. And everything Bryan just went through is in one of those guides, the one called WISE Science Image Access. And so it's all full of screenshots, everything he just talked about in a PDF. So you don't have to remember all those details. And just FYI, here's a picture of the 57% of the sky that was released earlier this spring. And so this is the Milky Way running right across the middle here. Down here you've got the Orion Nebula area. Up here around Rho Ophiuchi, you can see just those clouds. They glow great infrared. And you can look at it through your color filter cards.
Very cool.
And then we've been doing a lot of image releases over the last couple years. Here's some examples of like the Rho Ophiuchi region. There's another one of the Rosette Nebula. And then what I'm going to do now is kind of follow up and show you how you can make these same kinds of images yourself by downloading these same things directly from the archive yourself, just like Bryan did, and then using Salsa J. Before I jump into Salsa J, I just want to mention this other guide that we had you download. This we've created, we're going to turn it into a website connected to the WISE mission. It's just a big overview of what digital images are, BITS images, and how to make pictures, which we have all gone through and we understand. But it also mentions some of the other free image processing programs, such as ImageJ, and where to go to get ImageJ, plus some pretty awesome astronomy plugins for ImageJ. Salsa J is mentioned, which we really like. Micro Observatory Image is another free one available, which is very simplified, so lower level students can, it's the best way to go is Micro Observatory. And then GIMP, the new image manipulation program. Those of you who might be really used to Photoshop, this is a lot like Photoshop. And then this guide also mentions FITS Liberator, so if you don't want to use any of those programs, you have your favorite image processing programs such as Photoshop, you can convert a FITS image into a more recognizable format using FITS Liberator. So, any questions on that? Okay, great. Again, all those are free.
What's the zip file that we downloaded?
Okay, so that's what we want to open now. And that is going to contain the 4 images of Zeta Ophiuchi that Bryan demoed how to get out of the WISE archive. And so these are large FITS files. There's 4 of them, and they each represent the 4 different wavelengths that WISE used, that WISE looked at the sky. And so let's open all 4 of them up in Salsa J. Highlight them all, and you can drag them right over into Salsa J, and we'll do the rest. Doing some funny things. Okay. Interesting, this is behaving differently now. Okay, so then here we have all 4 of these images. For some reason, one of them opened in a different size box, but that's no big deal. All that here. And for each one, let's go through that process of making them easier to see and bringing out the detail. The first thing we want to do is single image operators and the logarithmic stretch. Have we shown this one? Did you go through that at all? So this is just very useful for making images a little more easy to see. I won't go into the details right now. We can talk about it later after this session. But basically go to Process, Single Image Operators, Log for each of the 4 images. So I'll do this. It's a very useful function. It just now became available in the most recent version of Salsa J, 2.2. So if you have 2.1, it's not going to be in there, just FYI.
They can do the auto, right?
You can still do the auto, yeah, which we definitely want to do. That window.
It's behind.
Is it hiding?
Yeah. Somewhere.
Let me see it. See if I can bring it up this way.
You probably minimized it. So you have it minimized somewhere. Yeah. You didn't bring it.
Can I show up?
One quick announcement. If any of you own a red Oldsmobile minivan, it's blocking their dumpster. Sorry.
Just perhaps to close all the images and go there again. Oh, that's it.
Just brightness contrast.
There you go. Oh.
That one.
You know what?
So funny
Close the pictures and open it. You have something mixed up there.
That's weird.
It's an abstract.
Yeah. What's going on? It's like Murphy's Law.
Should know it.
Right.
It's
Say no there, Kyle.
No, that's what I'm going on.
no.
Oh, you're being what?
Thank you, God.
Big brother.
Okay, let's do this again. While I'm doing this, you can go ahead and get ahead of me by doing the auto adjust of the brightness and contrast of each of these. After you've done the logarithmic stretch. Anybody else getting that problem? You know, it's probably the image file size.
There's a way you can change the memory.
Yeah, these are 32-bit.
Or you can even...
We can, but not quickly, not right now. I don't want to do it live, so just watch
You
it.
have even in South today you have this image.
Can you get this far? Rob? You can get that, convert it to 8 or 16, but just stick with the same for all of them. And let's see. Where is this thing? I don't know why this is not working.
Perhaps you have to kill South today and start it again. You've clearly lost it. Try reopening the device that has contact before you do the log. That's okay.
So actually what I just did to speed things up was I already had some of these saved in 16-bit format, so I'm going to use those instead. It should function just the same.
But the ones who have
There we go.
the ones who have are 32-bit.
These in particular are now 16. It's same difference though, just to avoid these live problems.
Yeah, it looks like maybe the header file still thinks it's 32-bit because it's displaying it as being 32.
Right.
Yeah, I think it is 32.
Yeah.
That's why I
Okay. Zoom through these. So again, I'm going to process single image operators. Logarithmic stretch. Goes black, but then you hit auto, and then it brings it all right back out. Beautiful stuff.
Very good.
Yeah. It's weird. I ran through this whole thing right before I went live, and it all worked perfect.
Maybe at the Ready Talk added too much memory to the system.
I think that's what's going on.
Yeah, that's the difference.
Yeah. Okay. So I've converted all of them and cleaned them up. Did this.
I think it's really to shut off the log rather than open to turn on the log.
I think it's been log stretched. We'll just stick with this for now for time's sake. Okay, so to combine these, we're going to do the same process that Rosa showed us just a second ago, except what's different here? We have 4 instead of 3. And Salsa J doesn't want to do 4. The best way to use all 4 is in Photoshop, and that's a whole other story. So what we want to do...
You can add 2 by 2, or you
Yeah,
can
so
do a stack.
There's some options. We can add some together. But in Weiss's case, a lot of times it's very, you'll look at the 2 images that show bands 1 and 2. And the way you know that they're bands 1 and 2 is that in the title of the image it says W1 and W2. The others are W3 and W4. There'll be a bunch of random numbers, but there'll be a W1, W2, W3, W4 somewhere.
Can you just stack them all?
You can combine these together, but what we typically do, just for simplification's sake, is because bands 1 and 2 often show a lot of the same detail, we'll just choose one of those 2. See how they look a lot the same? So we'll just eliminate band 1, the shortest wavelength. And now we will go to Image, Color, RGB Merge. And mine, by default, chose all the right settings. Yours may not, but remember, red is going to be W4, green is going to be W3, and blue is going to be W2. Click OK, and there's our pretty color.
Wow. So, what are the wavelengths again?
The specific wavelength wavelengths. The shortest one is 3.4 microns. The second one is 4.6, followed by 12 microns, and then the longest wavelength is 22 microns. And all that information is on the WISE website 100 times over.
Wow, that's neat.
So in this image, Carl, it's you're seeing blue is the 4.6 microns, green is 12 microns, and red is 22 microns.
And so basically the two shorter wavelengths are showing near infrared. The two longer wavelengths are middle infrared. In near infrared, we can see a lot more of the stars, the really cool, dim, tiny stars that are out there that don't show up so much in visible light. Those will come out in the shorter two infrared wavelengths here. And then in the longer two wavelengths, which are represented by green and red in this picture, that's where we see a lot more of the gas and dust that's glowing out there. So those H2 regions where stars are being formed. If you were to look at the same section of the sky in visible light, it would just be one bright star right there. Nothing else. So it's a really cool extension to using visible light telescopes to then branch a little bit into longer wavelengths and talk about how we can see completely different things in infrared. Is that making sense? Oh yeah, yeah. So bring up, if you want to bring up your little card with the different filters, sure. And you can take a look at your image. A little different here on the projector.
Red is boring.
Yeah, but notice, I guess the key difference here that you can see pretty quickly is that in red, you only see a handful of stars. Blue, you see a whole lot more.
Well, and the nebula.
You're welcome, Dad.
What was that?
You're welcome.
Oh, yeah.
You're the hero of the day.
Thank you. I'm jealous, by the way, of the Sophia flight. I didn't know you guys did that. So we are right at our time limit. So any questions?
Yeah, well, no, I just got one
Yes.
kind of simple method. In other words, this telescope, it does look like infrared.
Yes.
And there is where you can relate to it. You're shifting the image into the visible.
Right. So we're putting it into a form our eyes can see. Basically, our eyes wouldn't be able to see any of this, but the telescope's detectors
The
could.
telescope can see it. And so you're shifting the whole thing.
Yeah. And so we purposely then chose blue, green, and red in the same order from shorter wavelengths to longer wavelengths. We like to be consistent as astronomers. We didn't have to do that, but that's kind of the norm.
Does it mean one through four was longer to shorter?
Opposite. 1 is shorter, 4 is longer. So think of it as like wavelength. W4 is a bigger number of wavelengths. Any other questions? No?
So what was the sequence for the RGB merge? Red was which one would you be using?
We, for this one in particular, I did red for W2. Green was W3. Oh, no. I'm reversing that. Red was W4, green was W3, blue was W2. And then FYI, coming down the pipeline really soon is we're going to start creating some activities for using WISE data to find things like brown dwarfs by doing some photometry and picking out the different objects in there that match the specific colors that we're looking for brown dwarfs. Same with ULERVs, which are ultraluminous infrared galaxies. WISE was kind of fine-tuned specifically to find those two things, brown dwarfs and those ultraluminous infrared galaxies. So we're going to have activities where students can follow the same process as scientists. And then we're also going to use some activities to do rotation curves of asteroids and things like that, like Peggy was showing. And then very soon we're going to start doing a contest or a challenge is what we want to call it, to make your own pretty picture, color picture with WISE data, and we'll vote on it, and if you win, or your students win, especially your students is what we're really going for, we'll post it on the WISE main page as the image of the week and the featured image. So,
When is that planned?
very soon, probably in the next couple months or so.
Can you
Yeah,
make
we're doing
sure
a whole lot
that
of
I am informed of that?
What was that?
Can you make sure that I am informed?
Oh
of
yeah.
that?
This group right here is probably going to hear about it first. So yeah.
Very nice.
Thank Kyle.
Thank Bryan.
Yeah. Let me just note that, Bryan, particularly Bryan, has been, a tremendous friend of HLU and attended many of our workshops over the last 4 years. We've watched the advance of spacecraft and, getting the team together and seen the importance of the EPO work. It's really a joy to see the data now in an easily accessible format. So, great work, guys. So we have.
Thank you. Please stand by.